This is lesson 9, comparing linear and exponential functions. So in this lesson, you will learn how to determine whether a function is linear, exponential, or neither. You will be able to determine this using an equation, the graph, or a table of values. Let's first begin by looking at equations. So a linear equation will always have the form y equals mx plus b. An exponential equation will have the form y equals a b to the x. If it's anything besides those two forms, it would just be considered other. So let's take a look at a few and see if we can decide whether it's linear, exponential, or neither. All right, let's take a look at this form. Well, it looks like the y equals mx plus b form, so this would be linear. Well, this form has an exponent, but the exponent is not a variable, so it's not exponential. It doesn't look like the linear form because it has an exponent on the x, so this would be neither. Well, same thing on this one. It has exponents, but the exponents are not variables, so it's not exponential and it's not linear, so it has to be neither. This one here has a variable exponent, so this would be exponential. This one here sort of looks like the y equals mx plus b form, but in this case, b is 0, but this would be linear. And even though this doesn't look like the y equals mx plus b form, I know the graph of x equals 5 would be a completely vertical line at x equals 5. So I know that this would also have to be linear. Let's take a look how we decide if we're graphing. So linear equations will either have positive slopes, negative slopes. They could be completely horizontal lines or completely vertical lines. If the graph looks like any of these, then it would be a linear equation. Exponential equations could be exponential growth or exponential decay. And if the graph looks like anything else, then it would be considered other. So let's see if we can decide whether these are linear, exponential, or neither. Well, the first graph looks like exponential growth, so that would be exponential. This looks like a straight line, so this would be linear. This one doesn't look like either, so this would be neither. This here sort of looks linear, but it's not one straight line, so this would also be considered neither. This next one is exponential decay, so that would be exponential. And this one's a completely vertical line, so this one here would be linear. Now let's see how we can determine this if we have a table of values. So here's a table of values, and you're going to take a look at your y's, and you're going to ask yourself, what do I have to do to 2 to get to 5? Well, I can add 3. And then from 5 to get to 8, I could add 3 again. And 8 to get to 11, I can add 3. So if I'm adding or subtracting a constant amount, it would be a linear function. Let's take a look at another table. So again, I'm going to look at my y values. 8 to 6, well, I'm going to subtract 2. And then 6 to 4, I'll subtract 2 again. And 4 to 2, I will subtract 2 again. So this is also a linear function. So in a linear function, if you have to have a constant difference between consecutive outputs. This means when you're looking at y's, you either have to add a constant amount or subtract a constant amount. Here's another value. Well, if I look from 4 to 12, I would add 8, but 12 to 36, I would add more than 8, so it's not linear. But 4 to 12, I would multiply by 3. And then 12 to 36, I'd multiply by 3 again. And so on and so forth through my table. So now this would be exponential because now I'm going to be multiplying by a constant number. Let's take a look at this table. Well, 20 to 10, I could subtract 10, but then 10 to 5, I'm not going to subtract 10 again, so it's not linear. But 20 to 10, I could divide by 2, and then 10 to 5, I'd divide by 2. 5 to 2.5, I'm dividing by 2, and so forth. So this one here would be exponential because I am dividing by a constant amount. So if it's an exponential equation, you will have what's called a constant ratio between consecutive outputs, which means you have to multiply or divide. And let's take a look at another table. Well, if I start at 6 and go to 3, that means I'm going to subtract 3. But when I go from 3 to 2, I'm subtracting 1. So it can't be linear because that's not constant. Well, 6 to 3, I would divide by 2. But then if I took 3 and divided by 2, I wouldn't get 2. So it's not exponential. So if I can't find an obvious pattern, then it would be neither. So if you have any questions, please ask.